This is lesson 1.4, which is on ordered pairs. I would suggest pausing this video and working through these warm-up problems on your own, and then we'll go through them. So for both number 1 and number 2, we are going to simplify the expressions. So looking at number 1, we have 7y times 3. Well, using that associative property of multiplication, we can change around where the parentheses are. So instead of doing 7y times 3, I can change this to 7 times 3 times y. Now that I have that 7 times 3 in parentheses, I can multiply those together. 7 times 3 is 21, and then times y. The only way to write this simpler is to just write it as 21y, because when we have both a number and a variable, we don't have to put anything in between them. When we're multiplying, I should say. Number 2, 33 plus f plus 17, we can use the associative property of addition and switch this up so we can do 33 plus 17 in parentheses plus f. Then I can combine 33 plus 17, which is 50 plus f. I can't combine those because they aren't like terms, so that is my answer. Number 3 says to rent a popcorn machine, it costs $35 plus $7 for each hour. Write an expression to find the total cost of renting the popcorn machine. So with this, we know that it costs, whoops, that's not a highlighter. It costs $35 plus $7 for each hour. So that $35 is going to be a one-time fee. We have to pay $35 no matter how many hours we rent this machine for. And then every hour we also have to pay $7. So to write that, we can write that as $35 plus, and then 7 times x. And that's going to represent the cost we're paying for all of the hours we rent the machine for. Further on into the year, we are going to switch how we write this around, and we're going to write it with the variable and the number first, and then that constant number by itself at the end. So writing this as 7x plus 35. It's good to get in the habit of that. Then letter B says evaluate for 5 hours. So all we're going to do is we're going to plug 5 in for x and solve. So 7 times 5 plus 35. Then following order of operations, I have to multiply first. 7 times 5 is 35, and then I still have that plus 35. 35 plus 35 gets me 70, but since it's a word problem, I have to answer this in a sentence. So I'm going to write, it will cost.
Any staff that has students up to age 18 can go to the cafeteria and get meals.
$70. Excuse that announcement on the speaker. Here is some important vocab for this lesson. So in your note packet, I want you to label one of your graphs with all of these different vocab words so that you have them in the future. So the first word is coordinate plane. Coordinate plane is just this whole grid graph. We call that a coordinate plane where we graph on. An ordered pair is written as x then y. It has an x value, comma, y value, and it has 2 parentheses. The origin is the point 0, 0. So the origin is the point where both the x and the y axis meet. We always start at the origin when plotting ordered pairs. The x-axis is the horizontal line, and the y-axis is the vertical line. So y-axis goes up and down, x-axis goes left to right. The x-coordinate is the first number in an ordered pair. The y-coordinate is the second number in the ordered pair. Then we have quadrant 1, 2, 3, and 4. I'm fine if you write them as Roman numerals, or if you write the number, either way works for me. So quadrant number 1 is the box where both x and y are positive numbers. Quadrant number 2 is to the left of that. Quadrant number 3 is down. And quadrant 4 is that last box. So it goes counterclockwise. So think about it as going counterclockwise. Just some review. Points in a coordinate plane are represented by ordered pairs. The first number is the x-coordinate, the second number is the y-coordinate. So the point -2, 1 is shown to the right. The x-coordinate is -2, and the y-coordinate is 1. Since the x-coordinate is -2, that means we go to the left 2, and since the y-coordinate is +1, that means we go up 1 to plot our point. Okay, a little bit more review. Coordinates must have a parentheses. They must have a parentheses and a comma. The first number is the x-coordinate, so we move right for a positive number and left for a negative number. When you're plotting the y-coordinate, you go up for a positive and down for a negative. So you start your second number where you first ended. You don't go back to the origin. So just some examples. Given the coordinates of each point, we know that the coordinates go x, then y. So if we're starting at letter A, we need to get to letter A, and we do that by starting with our x value. So we have to go to the left, 1, 2, 3, 4. Since we went to the left, that's written as -4. And then we go up 1, 2, 3, 4, which is +4 since we're going up. Letter B, we're going to the left 1, which is -1. And remember, you always do parentheses and a comma in between. And then we don't have to go up or down, so our y-coordinate is 0. Letter C, well, we don't have to go left or right, which means our x value is 0, but we do have to go up 1, 2, 3, 4, 5. So we write that as 0, 5. Letter D, we have to go to the right 1, 2, 3, 4, 5, so that's +5 for our x, and up 1, 2, 3, which is +3 since we went up. Letter E, we go to the left 1, 2, 3, 4, not 4, just 3, so it'd be -3. And we go down 1, 2, 3, 4, 5, which is -5 since we go down. Then our last one, which is letter F, we go to the right 3, so that's +3 for our x, and we go down 1, 2, so that's -2 for our y. Remember, coordinates are always written as x then y, parentheses on the outside, comma in between. To plot these next 3 points, letter A, we start with -2 for our x, which means we go to the left 2, and then +3 for our y, so up 3. And then make sure you're always labeling your points. Super important that you label your points. Letter B is 1, -3. So we go +1, 1 to the right, and down 3 since it's negative. Label that as letter B. And letter C is 0, -4. So we don't go left or right, but we do go down 4. So it's going to be on the y-axis, and we'll label that one as C. Couple vocab words. A relation is a set of ordered pairs that can be shown in a table or a graph. Domain is all of the x-coordinates in a relation, and the range is all of the y-coordinates in a relation. So here again, relation is a set of ordered pairs that can be shown in a table or a graph. So we have all of our ordered pairs. We can break them up by x and y value and put them into a table. We can also graph them on a graph. So the biggest thing here is domain and range. Domain is all of our x values. The range is all of our y values, and we write those in order from least to greatest. So as you can see here, our x values are 1, 2, 3, 0. Writing that from least to greatest is 0, 1, 2, 3. Our y values are 4, 2, 0, 2. When we're doing domain and range, we don't need to repeat numbers. So since there's 2 2s, we only have to write that 2 one time. So our range would be 0, 2, 4. Practicing with that, this next question says to express the relation as a table, then determine the domain and range. So I have my ordered pairs. I'm going to make a table for my x and y values, and all I'm doing is I'm splitting up these ordered pairs into their x and y. So 4 and 1, well, 4 is my x value, 1 is my y value. 3, 2, 3 is my x value, 2 is my y value. 0, 1, 0 is my x value, 1 is my y. And 2, 3. 2 is my x value, 3 is my y value. Then it says determine the domain and range. So I'm going to label domain as D, and then we always do these fun little squiggle things with domain. Remember, domain and range, always written from least to greatest. So looking at my x values for domain, we have 4, 3, 0, 2. I write that from least to greatest, so we have 0, 2, 3, 4, and end it with my little squiggly. Range, same thing. I do my little squiggle line, and then I write in order from least to greatest. So here I have 2 1s, but remember I only need to write that one time. So I have 1, 2, 3, and end with my squiggles. So again, domain is my x values, range is my y values. Our very last problem here says to graph an algebraic expression. So the problem says Mrs. Gazelle's class is playing a quiz game. The difference between Allie and Jonah's score is 3 points. So we know difference means subtraction. So our expression is going to have subtraction in it. We know x is Allie's score, and we know y is Jonah's score. So here's a function table. A function table has an x column, a function rule, and a y column. So I'm going to start with my x. My y is going to go on the right, and then our rule goes in the middle. So we know the difference between their score is 3 points. I'm going to write that as x, because that's Allie's score, minus 3, which is going to tell us what Jonah's score is. Then it says to make a table for possible values, which means I get to pick which values I want to use for x. I look at my table because I am going to have to graph it, so I want to pick numbers that are on my table. I don't want to pick 730. So I'm going to do 3, 5, and 7. Then I'm just going to plug in my values for x and solve for y. So this would be 3 minus 3. So I plugged in 3 for x minus 3, which is 0. So my y value is 0. Then I'm going to plug in 5 for x. 5 minus 3 is 2. Then I'm going to plug 7 in for x. 7 minus 3, which is 4. So now it says to graph the ordered pairs and describe the graph. Well, we know that an ordered pair is written as x, then y. And we have both x and y values. So this first ordered pair would be 3, 0. Next one would be 5, 2. And the next one would be 7, 4. So now I can graph these. First one, 3, 0, go to the right 3, up 0. Second one, 5, 2, we go to the right 5, up 2, plot it. And the last one, 7, 4, we go over to the right 7, up 4, and graph it. So we've plotted our 3 points. Now it says describe the graph. Well, this graph is going up diagonally. So that's all I have to write. It goes up diagonally. And I never know how to spell diagonally, so don't you?